Hello everyone. In this video I'm explaining the coprocessor instructions. So we already know why do we need a coprocessor. The coprocessor will be interfaced with a main or a core processor in order to extend the functionalities or the capabilities of the core processor. So here a coprocessor can either provide additional computation capabilities, as I told, like either it can do a floating point operation like that. So there are so many operations that a normal processor cannot able to do. So in order to provide that additional capabilities, we are just using a coprocessor, and which also provides some instruction set. So apart from when we are trying to do some additional capabilities, we need some extra instruction that can be able to execute only by the coprocessor itself. That instructions cannot be able in the regular or a normal core or a general core processor. So whatever the things we are going to do in a coprocessor, it needs an instruction. That instruction has to be clubbed with the or else that instruction should be used to execute some additional capabilities. Now, as I told, apart from doing that like a floating point, it can also do it can control the memory subsystem, including caches and memory management things. So these are some of the additional functionalities that a coprocessor can do. Now let's get into the instruction that are supported by the coprocessor. The ARM instruction set will going to have three types of an instruction for communicating with the coprocessor. The first one is the ARM processor instruction to initiate the coprocessor data processing instruction. So to perform the data processing operations, there will be a one type of an instruction. Similarly, in order to transfer the data to and from the register to the coprocessor, we are going to have another type. Similarly, in order to generate the address for the coprocessor, load and store instructions will be provided by the coprocessor. As you can see in this table, as I told, there is a one type. The first type is a data processing instruction, which performs the coprocessor in the coprocessor itself. So it will going to perform the operation in the coprocessor itself. Similarly, there is another type of an instruction, which is MRC and MCR, which is used to transfer the contents between the registers, or else I can say that we can move the data to and from the coprocessor. Likewise, I can able to transfer the contents within the memory using this load and store for the coprocessor. Remember, LDR and STR will be used in a conventional core instructions. So in coprocessor instructions, we are using LDC and STC. So remember that one thing. In exam they may ask about what is the difference between a LDR and LDC. I like that we'll STR and STC. So you have to remember, whenever there is a C, you have to remember that this instruction is for coprocessor. Let's get into a syntax. As you can see here, this is about the data transfer instruction. So the first field, so this is the opcode for a coprocessor instruction, and then CP means it represents the coprocessor number. So there is a 16 coprocessor can be added to the main ARM core. With a starting number of starting from CP0 to CP15. So there are about 16 coprocessor that can be attached to a main processor. Likewise, I'm going to have an opcode and opcode 2, which specify which processor operation is to be performed. So as we know, there are around 16 processor, so it will going to specify which operation has to be done according to the coprocessor that has been used here. So likewise, in conventional instruction method, in a regular ARM processor, we are going to have a destination and then two sources. So similarly, we are going to have a destination, which is nothing but a CD. This C represents that it is a coprocessor. So this is a destination, and this is one of the source register. So So when I'm going to do register transfer, so I'm going to have two sources, CN and CM. Again, CD, that means RD. So either you can transfer the data from the main program to the coprocessor, and you can get the data from the coprocessor to the main processor. Again, this opcode is nothing but which we are going to specify which coprocessor operation has to be performed based on which coprocessor type has been used. Similarly for this instruction also, let's get into some of the example. As I told you, the CP field will going to represent a coprocessor which represents which will going to have the number between CP0 to CP15. That means starting from 0 to 15 means, so there will be overall 16 types of a coprocessor that can be added to the main processor in order to provide the additional computing capabilities, like a floating point. There is a different coprocessor. In this let's go to the example. As you can see here, I'm just using an MRC. So MRC means you are just transferring the data to and from the coprocessor. So this is my conventional ARM processor general purpose register, which is R10. So now this is a 0 register in the register 0 in the coprocessor 15. That means I'm just using a coprocessor 15. So in this coprocessor, this C0 represents the register 0. So now whatever since both the source registers are of same type, so whatever the contents of this source will be moved to the destination register. So now the contents of this R0 in coprocessor will be moved to the R10 in the main processor. So this is about the coprocessor instruction. So when they ask the question in an examination, you have to tell why do we need a coprocessor and what type of a functionality it will going to provide. So what type of additional functionalities, as I told you, apart from doing like a floating point, it can also manages or controls the memory subsystems, and it also manages the it also does the memory management job. So these type of a job or the additional capability can be provided to the ARM processor. Then you have to explain about the syntax and these three type of instruction, then with a normal example. So this is about the coprocessor instruction. Thank you.